In the previous presentation, we have seen how much time is required to add the data at the end of the single linked list. Now in this presentation, we will see how to add the data at the end of an array and how much time is required to add the data at the end of an array. So let's get started. Here we will consider two different cases. The first case is array is not full and the second case is array is full. Let's consider the first case, that is when array is not full. This is case number 1, array is not full, and here I will consider this program. Here in this main function, we have this array A which can accommodate up to 10 values, and we have this integer I, n and free pose. These are the three different variables we have. We will see the use of them later. Then we have a printf function which is asking the user to enter the number of elements, and here with the help of scanf function, we will store the number within this n variable. After this, we will use this for loop to ask the user to enter the elements within this array A. After this, we have this free pose equal to n. Here we are using free pose variable. Now what does this free pose variable do? Here this variable maintains the index of the empty slot in an array. Okay, so this variable is actually maintaining the index of the empty slot of an array. Here is how it is maintaining the index. Let's say user has entered n equal to 3. After that, user will enter 3 values, of course. Let's say those values are 1, 2 and 3. And this is an array A which contains these values 1, 2 and 3. After this, you can see that index number 3 is empty, right? So this is the index we are maintaining here in free pose. And here with the help of n, we are maintaining this index. We know that n contains the number which indicates the number of elements. We are using this number as an index of the empty slot, and we will store that number within this free pose variable. This is what we are doing here. So this is the empty slot we are talking about, right? And after that, we are calling this add at end function, and here we are passing the array A. Along with that, we are passing free pose as well as the data that we want to add at the end of an array. So here comes the add at end function which accepts array A, free pose and data. Here you can see this is free pose and this is an array. In the first step, what we are doing here is that we are actually using this free pose as an index to put the data within that empty slot. So A free pose equal to data means that we go to that particular index and we will store the data within that index. So here this will get updated by 65. After that, we will increment the free pose by 1, which means that now it is incremented by 4. This means that now the empty slot is at index number 4. After this, we will return this free position and this will get returned in the main function and it is received by this free pose variable. So this free pose will also get updated by 4 here in this main function. After this, we are using this for loop to print the data on the screen. This loop will run from 0 to free pose minus 1 and will print all the data on the screen. So here the output of this program is 1, 2, 3 and 65, right? And the time complexity of this function is big O of 1. Isn't that so? This function will just take big O of 1 time. And we should always remember that we have assumed that the array is not full. Let's consider the case number 2 when the array is full. And here is the program which helps us to understand what happens when array is full. Here in this case, I am considering this array which can accommodate up to 3 elements. Here again, we have these 3 variables I, n and free pose. And we are asking the user to enter the number of elements. User will enter the number. We will store that number within this n variable. And then after that, we are using this for loop which runs from 0 to n minus 1. User will enter all the elements within this array A. And then after that, we will calculate the size of the array. Let us suppose that this is the array which accommodates these values 1, 2 and 3. And I'm about to calculate the size of this array by using this formula size of A divided by size of A0, which gives us the size, that is 3. After that, we will use again this free pose variable. Free position variable will store the index of the empty slot. Here in this case, we don't have any empty slot. Please remember this point. Now, how to check that we don't have an empty slot or the array is full? Here we will check this condition, is n equal to size? This indicates that array is full. How it is indicating? You can see over here that n indicates the number of elements entered by the user. If it is equal to the size, that is the size of the array, that means the array is full. Therefore, we get inside this if construct. Here you can see that I have declared this B array which can accommodate up to 5 elements because the original size was 3 and 3 plus 2 is 5. Here you can take 3 plus 1 also. You can create just one empty slot also. But here I'm creating 2 empty slots. It doesn't really matter. After this, I'm just calling this add at end function. Here I'm passing array A, array B, size, free pose and 65. Please note that here I'm assuming that array is full, right? This array is full. Here I have taken this array A which can accommodate up to 3 elements and I'm assuming that user has entered 3 elements. That is why the array is full. After understanding that array is full, we will create the array B of size greater than the size of array A. It could be size plus 1 or size plus 2 or size plus 3, doesn't matter. You can choose any number of your choice. It depends upon how much empty slots you want to create. After that, we will simply call this add@end function, and here we need to pass these two arrays, of course, A and B, and size, free pose, and this data 65. This add@end function will receive all these data, and within this function we will declare one integer variable I, and after that we have this for loop which runs from 0 to n minus 1, and basically what this code does, it is actually trying to copy all the elements of A into B. That is what we are doing here. So here all the elements will get copied over here. After that we have these two empty slots in this array B. So here we will use this free pose variable to add the element at the end of this array, that is at this empty slot. We know that free pose contains this value, that is 3. So B free pose will give access to this empty slot and will store the data within it. We know that data is 65, so data will get stored over here. After that we'll increment the free pose by 1, that means this will get incremented by 1, and we'll return that free pose back to the main function. And here free pose will receive this. So this will also get updated by 4. After this, we will use this for loop to print all the data on the screen. Here it should be 0 to free pose minus 1. You should remember that you can't use n over here, because here if we use n, then we will miss this element, right? That is why it should be free pose. So the data printed on the screen will be 1, 2, 3 and 65. And of course in this case the time complexity of this function is big O of n, because here we need to copy the elements from array A to array B, because we know that array A is already full. And if array A is full, there is no empty slot available. Therefore, we need to create a new array and we need to copy everything from array A to array B. That is why order of n is the time complexity of this function. This copying is the part of adding the data at the end. That is why it is counted over here, and the time complexity will be big O of n. So to summarize, linked list with traversal takes order of n time, and linked list without traversal takes order of 1 time. We know that in case of linked list we have two different scenarios. One with traversal and one without traversal. In case of array, when array is full, then we have this order of n time complexity. When array is not full, the time complexity is big O of 1. You can see over here that linked list has an advantage over array. Why is that so? Because we can't guarantee that when array is full and when array is not full. If array is full, then the time complexity will be big O of n. If array is not full, then it is big O of 1. We can always control the traversal procedure in case of linked list. We can avoid traversal. So time complexity can always be big O of 1. So linked list has an advantage over array. Okay friends, this is it for now. Thank you for watching this presentation.